That's what I'm laughing on.
Alright, is there any grade 10 learners that are here? Grade 10. Any grade 10 learners that are here? Any grade 10 learners that are here? Grade 10 maths learners here? Please in the comment section. Alright. Grade 10, grade 10, grade 10. Any grade 10 learners here? Andy Swakiti, Kaz, and Petro. Are you guys in grade 10? If not, please, if you are, please let me know so that I can at least know, because what's the point of doing revision if there's no grade 10s to actually receive the revision? I'll do grade 9 tomorrow morning as usual. Grade 9. 5 a.m. Saturday. What about it? 5 a.m. Saturday. I'll do some grade 9 paper. What paper? What paper you'd like done? Because if grade 10s don't arrive in this session, I'm going to cancel this grade 10 session and just go ahead and do grade 9. So since I don't see any indication, there's nothing in the comment section, no one is saying anything, so I'm taking it by assumption there's no grade 10s in this live. Since there aren't, then I'll kindly and gladly move on to another grade and do something relevant to them. No, to me. Oh my goodness. Yeah. Hi guys, I am so like sick of people saying this or asking this. Is it going to come out like this? Is it gonna be like this? Guys, what's important here is to revise the work that you've done for the year. The topics for grade 10 maths paper 1, you should know what they are. Okay, so for instance, this paper is just an example of a paper. Okay, this is an example. Okay, it's an example. So we have paper 1, and in paper 1 the first topic is you do number systems. All right, so underneath number system you have this whole idea of integers, whole numbers, natural numbers. So you must know your work, the difference between a rational and an irrational number, what is real and non-real. So you need to understand the number system. Okay, being able to find any two rational numbers between these two, showing that this number is rational, inserting an irrational number between these two, rounding off the following numbers to the number of decimal places indicated, because you need to know how to round off numbers to a certain decimal place. Being able to represent numbers on a number line when they are in set builder notation and in interval notation. And then being able to identify values of x for which an expression is undefined. Know the difference between undefined and non-real. Okay, so that's like, yeah, this is not going to be how your paper will come out like, but what's important here is understanding the concept behind these things. You must know, so this is just, it's an example. You need to master the concept and you need to be able to apply it to various scenarios as a grade 10 maths learner. That's what's important here. Not will it come out like this? Is this the paper that we are going to write? I don't have the paper that you are going to write in your respective regions. I have no idea what paper you will be writing. So for instance, some grade 10s wrote today in another province, okay, and their paper is most likely going to be different from the paper that you are going to write, which you haven't written yet. Okay, so I'm just here to sort of like help remind you, because some of you don't get an opportunity to have revision sessions done, so I'm here to remind you and to revise with you. So guys, if you are in grade 10, you are in the right place, okay, because I want to revise a particular paper that has grade 10 maths paper 1 content. Then after that, there's these types of questions: expand and simplify. Hopefully we still remember how to expand and simplify. Then factorizing. Hopefully you know how to factorize. We still remember how to factorize. You know the different types of factorizations that we have. Simplification of algebraic fractions. Division of binomials over a trinomial. Alright. Also, fractions that are algebraic that you divide. What happens when you do that? Addition and subtraction of algebraic fractions. How you deal with that. Okay. And then, like I said, simplification using your laws of exponents. Exponents, guys. Exponents. Alright? Exponents. Simplification of exponents. Okay. Further simplification of exponents. Okay. Yeah. Numbers. You know. Yeah. I hope you guys are, like I said, these are the important things here. Exponential equations, you see, how to solve exponential equations, solving more equations, okay, simultaneous equations, more solve for x, okay, yeah, so I'm here, guys, for grade 10s to help revise that. Okay, then of course we are also going to do a little bit of functions as grade 10s. That's what I'm here for. So and number patterns. There's also financial maths. Then there's also probability. Okay, so my hope was to actually come here and get you guys sort of like sensitized to the things that you are supposed to actually know and do. So if there are sufficient number, if there's really grade 10s here, let me get an indication in the comment section, guys. Okay. You've seen what I have lined up for you, right? So where would you like us to start? What is the consensus among grade 10s? What specifically would you want to attend to? Do you want to do number system type questions? Do you want to perhaps look at expanding and simplifying, factorizing, or addition and subtraction of algebraic expressions, fractions, division and multiplication? Do you want to perhaps focus on a little bit of exponents? What is the feeling in the house? What do you guys think? But please don't comment in jail. Comment if you're in grade 10. What would you like? Or would you like to do functions? Fractions. You mean these? You want to do this? Cinnamon girl. grade 10, you want to look at, am I correct? The girl with cinnamon. So should I start here then? Okay, Dr. Indy is like, yes. Okay, so I must start here. So I must leave this in factorization. Let me go start here. Okay. Well, let's get this show on the road. What is that thing saying? No, what? You guys are, you see, you're all over the whole of question 3. This is not question 3, this is question 2. Okay, are we seeing the numbers, guys? Hey, you see, that's the other thing. If we don't see numbers and we are writing other numbers, that's another problem. Okay, let's start there at the top. Question 1. Expand and simplify the following. X plus 6y into x minus 3y. So I'm sure you guys know, guys, that this is a binomial. Okay, and this is another binomial. So you have a multiplication of 2 binomials. Okay, but of course, when the binomial is in bracket, it stops being a binomial, it becomes a monomial. So you actually have monomials that you are multiplying together. We call them one term the minute you put them around brackets. Without the brackets, it would just be 2 terms. So let's look at this then. X plus 6y. Okay, remember the question says expand and simplify. So Dr. Dindi, I'm sure you would know what to do. We use here what we call the distributive law for FOIL. And we make sure that S and L, meaning the sign is multiplied first, the numbers are multiplied second, and then the letters are multiplied third. As we distribute, we make sure the signs are multiplied, the numbers are multiplied, the letters are multiplied. Hopefully we remember that a positive times a positive is a positive, and a negative times a negative is a positive. In the same vein, a negative times a positive is a negative, and obviously a negative times a positive is a negative. So if we know that, then this should not be too difficult. So let's start here. Positive times a positive, because this is a positive 1 before there. Positive times positive is positive. 1 times 1 gives us 1. Then x times x gives us x to the power. Remember, we add the exponents when we are multiplying single bases. So that's x squared. That's the first term. Then we say x times negative 3y. Positive times a negative is a negative. So if you are in grade 9, this is also applicable to you, because grade 10s do grade 9 work. That's something that you need to know as a grade 9 learner who's going to grade 10 pure maths. They do a lot of grade 9 work that you've just done yourself this year, so don't forget it. Positive times a negative is a negative. 1 times 3, or that is 3. We multiply the number. Then the letter. X times y. Then this is xy. This is maths. We are doing expanding and simplifying expressions. Thank you so much for the roses. Really appreciate it. Then you say 6y times x. Okay. Positive times a positive is a positive. 6 times the coefficient of x is 1. 6 times 1 is 6. And then y times x. That will give us xy. Remember, you can say yx or you can say xy. In multiplication, the order of the letters doesn't matter, because yx and xy mean the same thing. These are like terms. Then lastly, we say 6y times negative 3y. That means a positive times a negative is a negative. That's the sign. 6 times 3 is 18. And then y times y, the bases are the same. When we multiply same bases, what do? We keep the base, we add the exponents. So this is the expression we get after applying the distributive law, multiplying the first, outer, inner, and last letters, applying multiplication of the sign first, then the number next, then the letter last. Then we now check for what? For like terms. X squared. these two middle terms are like terms. So what we do when we are adding and subtracting like terms is we keep the variable xy will stay as it is. Then what do? We add and subtract the coefficient. So -3 plus 6 is equal to +3. So that becomes +3xy. And then the last term is -18y squared. We stop right there. We cannot add these terms. Why? Because they are all called unlike terms. Terms are separated by a plus and a minus sign, and we say x squared, 3xy, and -18y squared are unlike terms. We cannot add unlike terms, so we leave our answer as 3 separate terms like this. We don't go any further. That's how we answer the first question. Hopefully, Dark Dindy. Can I move on to the next question? Dark Dindy. Dark Dindy, I don't know what your actual name is, so I'll call you Dark Dindy as per the WhatsApp name. I mean the TikTok name. Okay, I can move on. Next question. 2 into 4x plus 6 minus 3 into x minus 2, the whole thing squared. Same question. Expand and simplify the following. So first things first. We first need to establish how many terms do we have in the expression. So how many terms do we have in the expression? We have 1. This is one term. Then this minus sign separates. This is 2 terms. So we have 2 terms in the expression. Number 2. This 2 and this bracket 4x plus 6. What can I do with it? Well, I can distribute for the first term 2 into 4x and plus 6 using the what? The distributive law. Okay. Then let's come here. Minus 3 with brackets x minus 2. Then here there's an exponent. Guys, there's this thing that we always make sure that we are applying called bad maths. Whenever we are seeing a relationship between brackets b, e, exponents, d, division, m, multiplication, a, addition, s, subtraction. As you see with the second term, there's a bracket, there's an exponent. I can't apply the multiplication of 3 inside the bracket until I take care of the exponent. That is what bad maths tells me. Okay? Bad maths tells me exactly that. So what I have to then do, okay, I know I'm going to distribute that, but I'm going to do this with x minus 2. This exponent is saying open 2 brackets of x minus 2. So I'm going to do that. I open those 2 brackets. Okay? Right, then watch me work. 2 times 4x. Remember, when I multiply 2 and 4x, I apply S and L. I multiply the sign. Positive times a positive is positive. And I multiply the letter. 2 times 4 is 8. The x next door to the 8. I distribute 2 to positive 6. I do the same thing. Positive times a positive with the sign positive. Number 2 times 6 is 12. Now here, because the exponent, I open 2 brackets as per the exponent 2, x minus 2 and x minus 2. What I then follow that up with is this 3 for now. I'm just going to allow it to stay outside, and I'm going to deal with these 2 brackets by distributing using first terms I multiply, outer terms I multiply, inner terms I multiply, and last term I multiply. So this is just applying the distributive law using FOIL. So we go put the 3 outside for now until further notice. Then we multiply. What's x times x? That's x squared. x times the negative 2, positive times the negative is negative, x times 2 is actually 2x. Do the same thing here, negative 2 times x. What's negative times the positive? That's negative 2x, all right, the whole thing. Then negative 2 times negative 2, that gives me positive 4. Because remember, negative times negative is positive, and 2 times 2 gives me 4. 8x plus 12, I take it down. Minus 3 still waits patiently outside until it can be allowed to come in and be distributed. For now, we sort out what's in the brackets. We add the like terms inside. We have x squared. What's negative 2x minus 2x? That's, we keep the variable. We subtract the like terms. What's negative 2 minus 2? That gives us negative 4. Then we have that plus 4. Now please take note of what I'm going to do next. 8x plus 12. We still are taking that down. We can't say 12 minus 3. We can't subtract these two. Why? Because this negative 3 has a relationship with the bracket. And in maths, what do brackets mean? Brackets mean multiply. So our priority is to take the negative 3 and distribute it to all 3 terms inside the bracket. So that's why we can't say 12 minus 3, for instance, and say 12 minus 3 is 9. We can't do that because this negative 3, it's like it's in a marriage. You know, when you are married, you are committed to your entire family, especially if you are the head of the household, like this negative 3. You are committed to your household, to your wife, to your kids, and everyone in that household. They depend on you. So you can't, you know, at the first sight, you know, because of you can't just say, 12, let's do something together. No. Negative 3 needs to be distributed. He has a household. So think about negative 3 with the bracket being like a father and his entire household. There's commitment there. You can't take 12 and subtract 3 because bad math. Brackets, exponents, brackets, exponents, right? We took care of exponents. Division, remember the 3, negative 3 and the bracket mean multiplication. Brackets mean multiply, and this negative 3 has an entire household to take care of. So we distribute. Then when we distribute what's negative times positive x squared, we get negative 3x squared. Negative 3 times negative 4x. This is for grade 10, but applicable to grade 9 as well. Negative 3 times negative 4x. That gives us positive 12x. Okay. And then negative 3 times positive 4. That's negative 12. Now you have terms that are separate, and you can finally apply what? Multiplication has been taken care of. Now you can add and subtract any like terms that you see there. Use a 6, 4, 8, 9, 9, 9, 9, 9, 9, 9. You said x minus 2, the whole thing squared. How many x minus 2's do we have if we're saying we put the exponent to? Remember, guys, that an exponent is a device that basically means repeat this that you have in the bracket. So if I say repeat this how many times? Once by itself, that means I open 2 brackets to use x minus 2. We don't say, as you have said, that you're going to write x plus 2, x minus 2. That's a misconception. Use a 6, 4, 8, 9, 9, 9, whoever you are. Okay? So this is grade 10 already. I don't understand why someone is coming here and saying do grade 10. This is grade 10. Okay? But obviously also applicable to grade 9. Now that we have like terms, okay, negative 3x squared is on its own. 8x plus 12x, those are like terms. 8x is positive, 12x is also positive. So we say 8x plus 12x, we get 20x. Then 12 is positive. This 12 is negative. What's 12 minus 12? It's equal to 0. Our final answer is negative 3 x squared plus 20x, these are two unlike terms. Why? Because this term has x, this term has x. So easy to think these are like terms. This term has x, this term has x. But because of the different exponents, that's why we say these are unlike terms. Different exponents make it such that these become unlike, so we leave the answer as you see it. We can't go on any further. Okay, so once again, the person that basically said I must start here, Duck Dindi. Are we together, Duck Dindi? This is grade 10, guys. Why is everybody saying? Okay, thank you. Let's move on to the next one. We are done now with questions that have to do with expanding. Guys, this is grade 10 revision. Next question. 2x to the power 4 minus 32. Factorize the following expressions. So we are going to factorize each one of these. The first one, 3 marks. Second one, 3 marks. And then the third one is 2 marks. So let's go ahead and factorize these. It's fine that it's easy, Kalogotavi, so that's good for you. And I'm glad that it's easy. Okay. Remember, being easy may be easy because of what you know, but for some people it may not be easy because of what they don't know. Hence we are here. Okay, if we are going to factorize this, what's the first thing, guys, we always ask ourselves before we factorize anything? The first question we ask ourselves when we are about to factorize anything, what do we ask ourselves? Okay. Well, how many terms are in the expression? There are 2 terms because terms are separated by a plus and minus sign. That's the first thing. So there are 2 terms in the expression. Number 2, is there a highest common factor? That is the second question. That's very important. So the question is there a highest common factor? And when we take it out, we must take it out according to the sign. Whatever the sign of the first term is, that becomes our highest common factor sign. We take it out according to the number. We look at 2 and 32 and we ask, what is the highest common factor number between 2 and 32? We take it out. Then later, we look at the variables of each term. If there's a common variable, guys, we always take out that common variable that has the lowest exponent. That's if the variable or the letter of the alphabet is common. So if we look at these 2 terms, my question is to you, is there a highest common factor? The highest common factor sign is obviously going to be positive because our first term is positive. The highest common factor number between 2 and 32. Guys, what's the highest common factor between 2 and 32? What is the highest common factor number between 2 and 32? I'm busy with grade 10 and you're asking me to do grade 10. Thank you, it's 2. Okay, it's 2. What is the highest common factor letter? Is there a highest common factor? Is there a letter that is common? Is there a letter that is common? No, there isn't. So that means our highest common factor, guys, is 2. We take it out. Outside the bracket. Okay? So there it is. So if you take out the 2, what's left inside the bracket for your first term? You take out the 2, what's left for your first term? X to the power 4. Thank you, Jeremiah. Yes, Busiswan Goenya, thank you so much. And then what's left for your last term? Very true. 2 times what gives us negative 32. A positive times what gives us a negative? It's a negative. 2 times what gives us 32? Or we could say what's 32 divided by 2? That gives us 16. Okay, so that's negative 16. Thank you so much. Very good, guys. You guys are 100% correct. Now we would think that we are done with our factorization, but we always, after taking out the highest common factor, go back to the bracket and then we ask ourselves, can we factorize this any further? Okay, so when we look inside, x to the power 4 minus 16, x to the power 4 is what we call a perfect square. Okay, we call this a perfect square. 16 is also what we call a perfect square. So I use the word PS, but you get the point. What are perfect square numbers? These are numbers and variables. For instance, a perfect square variable is a variable with an even exponent. Okay, that's what a perfect square variable is. Okay, perfect square variable is a variable or a letter that has a even exponent. So for instance, this exponent 4 is an even number. Yeah, other examples, x to the power 8. That's a perfect square variable because it has an exponent that is even. X to the power 12. That's a perfect square variable because it has an exponent that is even. 16 we say is a perfect square number. Why? Now, why do we say 16 is a perfect square number? Perfect square numbers are numbers that are formed by multiplying a certain natural number by itself. Okay, so for instance, 16 is formed by 4 times 4. Okay, so that's why we say 16 is a perfect square number. So what we then have here inside the bracket is what we call a difference for D of 2 perfect squares. Difference of 2 squares. So that means we can now apply that kind of factorization inside the bracket. Thank you so much, Lucas Saint. We can now apply that factorization of difference of 2 squares for this bracket. We can factorize further. So we keep the 2 outside the bracket. Then we open 2 additional brackets. Now, what we then do is we take our first perfect square, which is x to the power 4, and we ask ourselves, what is the square root of x to the power 4? X to the power 4 is the same thing as x to the power 4 divided by 2. What does that give us? X to the power 2. This is the square root of x to the power 4. It's x squared. So that means I'm going to write x squared and x squared for both of my brackets as my first term in each bracket. Make sense? Then I'm going to go to this second perfect square. Do the same thing. What is the square root of 16? Square root of 16 is equal to what, guys? Square root of 16? I'm sure you know what the square root of 16 is. Yes, so thank you so much. It is 4. Okay, so now I do this. I write 4 and 4. Now, inside my bracket, because my last term is negative, this means something. When your last term for difference of 2 squares is negative, that means your brackets, inside your brackets, you are going to have different signs, not the same signs. You are going to have different signs. When your last term is a negative term, then it means for your difference of 2 squares, you are going to have different signs inside your bracket. So I know I'm going to have a positive and a negative. And I always start with the positive sign and end with the negative for a difference of 2 squares. Now, someone will think that they are done with factorizing, but in actual fact, we are not done. So what we do is we look at the bracket that we have and check again. Can we factorize these 2 brackets any further? Can we factorize these brackets any further? Why not put a negative inside of the square root? Further, come on. The 16, we are finding what is the square root of 16. Okay, never mind the sign. We are saying what is the square root of 16. Because if you were to say what is the square root of negative 16, you know that if you take the square root of a negative number, it is not a real number anymore, but it is non-real. Okay, it is non-real. You can't do that. We can't put a square and negative number inside a square root. Okay, calculator says maths error. That basically means for a negative number to be underneath a even root, that is non-real. So we take the square root of 16 as a positive number. We establish what the numbers are. Then the signs, we will write different signs inside the bracket. Why? Because our last term for difference of two squares is negative. We put different signs, a positive for one of the brackets and a negative for the other bracket. Think about it now. If you were to FOIL this back, x squared times x squared, isn't it x to the power 4? Yes, it is. Then you would continue and say x squared times negative 4x. X squared times negative 4, you would get negative 4x squared. Then you would say 4 times x squared, you would get positive 4x squared. And then those like terms would actually give you 0 for the middle term. So you would have no middle term. Then lastly, you would say positive 4 times negative 4, which will give you back the negative 16. So that is why we have a positive sign for one bracket and a negative sign inside the other bracket, because we know this is what will bring this back to this expression. Anyways, let's continue. Now, we would think that we are done with factorization, but you know what, guys? This bracket, we cannot factorize any further because it's a sum of two squares. This second bracket, you can see we have again x squared. It's a perfect square. 4 is a perfect square. We have a minus sign. What does that mean? It means we apply difference of two squares factorization to the second bracket. So I'm going to do this. We are going to retain and keep x squared plus 4. Then we are going to open 2 additional brackets. This is where people lose marks, because people think that when they factorize up until here, they are done. Then they don't continue and see that, oh, we can even continue further. And then marks are lost. So let us be vigilant of this type of factorization, which we refer to as what? Difference. Difference means minus. Okay. If you go back to mathematical language, if you say the difference of something and something, you are saying the subtraction of those two things. The difference of what? Of two perfect squares. This variable, a perfect square, why? Because as I said, a variable with an even exponent is a perfect square variable. This 4 is also a perfect square what? Number, because it is formed by multiplying a certain number by itself, which is what? That number. Okay, we are going to check it out. So what is the square root of x squared? The square root of x squared, when we remove the square root, it becomes x. So we are going to place x and x. Okay. Then what is the square root of 4? The square root of 4. That gives us 2. So then we are going to place what here? 2 and 2. And remember, what did I say to you guys? I said, since there's a negative last term for this bracket, thank you, we put what here? Plus and minus. Now, can we still factorize any further? Can we still factorize any further? No. So that's where our factorization comes to a beautiful end. Any questions at all? Okay, I think that's clear enough. Let's continue. So let's take note of the different types of factorization that we have. Next question. Grade 10. Grade 10. Negative 2a into 4x minus 1. This we can't factorize. We are done factorizing here. We are done. Now we are looking at another question that says factorize. Negative 2a into 4x minus 1 plus 6b into 1 minus 4x. Factorize the following algebraic expression for 3 marks. How do we proceed? First question we always love asking ourselves when we are factorizing: how many terms in the expression? So I want to ask you guys, how many terms do you see in this expression? Let me see in the comment section what you guys think. How many terms are there in the expression? How many terms? Before you rush for common brackets, thank you, Yolanda. Yolanda, you are the best. Yolanda says 2 terms. Thank you. Second question. Okay. Is there a highest common factor? Because we always ask ourselves that fundamental question. Okay. But before that, let's look at our terms, guys. Let's look at our terms. There are 2 terms. This is our first term, remember. Okay. A bracket makes this become 1 term. Multiplication, 2a multiplied, the bracket means multiply. Multiplication combines terms. That's why we say negative 2a into 4x minus 1 is actually 1 term. Then 6b into 1 minus 4x, this is a second term. Plus separates this term and that term. So we have 2 terms in the expression. Now, someone said earlier on when they were thinking about is there highest common factor, someone said common bracket. Now I want to ask, is 4x minus 1 and 1 minus 4x a common bracket? Do we know what a common bracket is, guys? A common bracket is a bracket that basically looks exactly the same with the other one. Okay, Busisi Wengwenya says that is not a common bracket, so does Jeremiah. Why do we say these 2 brackets are not common? Okay, 4x minus 1. This 4x, you can see, is positive. This 1 is negative. Okay, this one, unlike this one, is not negative, but this one is positive. This 4x, unlike this 4x, is what? Negative. Now, Cinnamon Girl in the comment section, and I'm going to pin Cinnamon Girl's comment. No, these are not common brackets, but Cinnamon Girl says, but you can multiply with the minus to change it. Okay, so if we look at this bracket, we love this bracket because the x term is first and then the constant number term is second. So we would want to then change this bracket to be aligned with this one. And as per the recommendation by Cinnamon Girl, cinnamon tastes so good, we can actually then do what she has said, Cinnamon Girl. We apply something called the SCR. You know, doctors have a procedure that they apply to patients when they are losing breath or when they are out of breath. We call that procedure CPR. So we have a procedure called SCR. We call this the sign change rule. It's a procedure that we perform when we can see common brackets are not happening, but one bracket has a different order to the other one, and a minus sign is evidently between both of the brackets. This is what's important. The order is different, but evidently between the two terms inside the bracket, there's both a negative sign for both the brackets. That's when we apply this procedure. So as Cinnamon Girl said, we can change this bracket to be aligned with this one. How? It just means, you see this plus sign that you see here? We simply sign change it. How? This plus sign becomes negative. Then we can comfortably change the order of 1 minus 4x to become 4x minus 1, and thus having a common bracket. We didn't have one, but now we do. Let me just get back again. What did I say to you guys? There is a procedure that we apply whenever we do not have common brackets, and those common brackets both have a negative sign between their terms, and it's just that it's the order of the terms that is a bit off. I repeat, we apply the procedure of sign change rule when we have minus sign in between terms in a bracket, but the order of those terms make it so that the brackets are not common. Okay, that's when we apply this procedure. What does the procedure entail? What do we do when we apply the procedure? We change the sign and we change the order. Hey, the sign change rule says we change the sign. It was positive, now it's negative. Then we change the order. Now listen up. If I was to take this negative sign, just it alone, and distribute it to the 4x, what happens to the 4x? This negative times this positive 4 will give me back my negative 4x. Do you see that? This negative multiplied by the negative 1 will give me back my positive 1. That is why changing the sign of this 6b, which is positive, to being negative allows me to then have a common bracket that still maintains the identity of the original expression. The original expression has not really changed, but it's just that I lungiselela it. I actually align my brackets in such a way that when I change the sign and the order changes, then I'm able to still retain the original expression and what it was. I hope this is sinking in a little bit. Those who may have forgotten, I am reminding you of what you had done in term 1. You are now in term 4. You are preparing to write your paper 1 exam in grade 10. And what we need to ensure is that we don't leave any stone unturned. Now we can factorize. Is there a highest common factor? Hey, guys, this highest common factor, it's there, it exists. How many terms do we have? We still have 1. This minus sign separates 2 terms. I'm going to say to you, is there a common factor? Now, depending on who you are, all right, me, I would say, is there a highest common factor? And when I say that, I am going to look at highest common factor in terms of sign, number, letter, and if there's a common bracket, SNLB, sign. The first term has a negative sign. So now it means I can take out a negative sign as a highest common factor. Because guys, whatever the sign of the first term is, that is the highest common factor sign you take out. Is there a highest common factor number? Let's look at 2 of the first term and look at 6 of the second term. Is there a highest common factor between 2 and 6, guys? And what is it? I've already taken out the sign. So the sign has already been taken care of. Now I'm looking at the number. Is there a highest common factor between 2 and 6, and what is it? I'm sure some of you are like, what is this guy doing? Guys, highest common factor, sign, number, letter, bracket. Thank you, God's very own. Thank you, Jeremiah. Highest common factor number is 2. Thank you. Is there a highest common factor letter? A, B. No, A and B are not common. So we have no highest common factor letter. We move on to B. Is there a highest common bracket? Well, look at 4x minus 1. Look at 4x minus 1. Is 4x minus 1 common? 4x minus 1 is definitely common. So we take out 4x minus 1. This here is our highest common factor. Negative 2 into 4x minus 1. That is the common bracket taken out. Then what is left over on the left? Remember, I took out this negative 2. This negative 2, it's out. This A, we didn't take it out. So what is left behind on the left-hand side of my term? What is left behind, guys? What is left behind on my left? Let's look at the left first before we go to everything. What is left behind on my left? Let's start there. My left term is negative 2a into 4x minus 1. So what is left behind on my left? Thank you, user 648. Thank you, Jeremiah. We are left behind with a on the left. Let's move now. Is there anything else? No. Negative 2 out. 4x minus 1 is out. What is left? Only a. Then negative times what gives you a negative? This is very important. And negative times what gives you a negative? Because we need to have a sign that is appropriate here. Negative times what gives me a negative? Thank you, Chantal. It is positive. This is the sign that separates. Now, I took out a negative sign, so obviously the sign that now separates is positive. This is very important, guys. Hey, what I'm saying is very important. Then, let's move over to my right term now. Where am I now? I'm moving over to my right term. Negative 2 was taken out. Negative 2 times what? Sorry, the sign is already taken out. 2 times what gives us 6? And then what about the b? 2 times what gives you 6? Let's start with the number. 2 times what? What's the number that I'm going to write here? Thank you, Chantal. We have 3, which is the number. What else is left behind on the right? 3 is definitely going to be left behind. What about b? Is b left behind for the right term? Yes, guys, b is also left behind. 4x minus 1, do I write out? I took out 4x minus 1. Do I need 4x minus 1 on the other side again? Doesn't seem like it. So I would say we are done. We are done, guys. This is the factorization of this. Finished. It's like hands down. It has been factorized. We can't factorize any further. If you look at this bracket, there's nothing more that can be factorized. You look at this bracket, there's nothing more that can be factorized. Guys, factorization is of utmost importance. We need to be masters of factorization. Do not forget, I nearly said CPR. the procedure, guys, that we apply when brackets are not common and the sign in between the terms is what? Is negative for both. We can apply the procedure that says what? Change the sign, change the order, change the sign, you change the order, change the sign, you change the order. Then, please guys, after doing such, you must then ask yourself, is there highest common factor? Even though initially you are going to say, I see a common bracket, please don't rush in just seeing the common bracket. Check first. Is there highest common factor sign? Is there highest common factor number? Is there highest common factor letter? Because I can promise you this, rest assured, most people, let me tell you what most people would do, right? Most of you learners do the following. Once you are able to do the change the sign, change the order, what you then guys do, I'm just going to show you here. You do the following. You say, you see the common bracket and you get excited, right? So then you take out 4x minus 1. I know you guys do this. You take out the common factor, common bracket, because you're so excited. Like, yeah, common bracket, yeah. And then what you do is you write what is left over, right? On the left. So obviously, I know my good students will write negative 2a, right? And then they'll write what's left over on the left, on the right. And they'll write negative 6b. And you know what, guys? They end right there because they're like, common bracket has been taken out, happy days. But if you are a student that thinks further, when you have done this, you are going to check this bracket. Is there highest common factor? No. Okay, even though it's 1 does not have any significance. You check this bracket, is there highest common factor? And that's where my very good students who check the bracket is, can I factorize this any further? And the answer will be in your head, yes, I can. So what do? You will take out the highest common factor that you see in this bracket. When you take it out, you take it out as negative 2 for the entire bracket, guys. So then you are left with 4x minus 1. Obviously, that 4x minus 1 is still there. Into, now check this out. Since you took out a negative 2 for this bracket, what gets left behind? A that is positive. Remember, you took out a negative 2, so there's a that is positive that is left. And then for this last here, negative 2 times what gives you negative 6? Positive 3b. Then those learners, they complete the factorization. So you may have not necessarily done the question the way that I have done it here. But how important it is, guys, for you to always check your brackets and see, can we still factorize further? Because if you can, then you must do so. Okay? That's what you can do. Okay? Thank you, Jeremiah. I appreciate your comment there. Guys, like, that's what you guys could at least do. Tell me about it. Tell me about it, Jeremiah. Tell me about it. But you know what? I've forgiven you. I've learned that your generation of kids are so entitled. You know, some of you, you could swear you pay me to do these live lessons. I see people come in and they say, do geometry or do trigonometry. Like, they don't ask, they don't plead, they don't ask in a nice way, like, do this, do that, do this. Or like they just, they sit and they watch and they just enjoy. They're like, oh my goodness, this guy is God sent, free lesson. Funny people, eh? Anyways, next question that has to do with factorization is this one. Trinomial. Okay. 2x squared minus 7xy minus 15y squared. This is a trinomial and the question is saying factorize. So, my dearest children, how do you factorize a trinomial? A quadratic trinomial. Look at this. This is 2x squared. This is minus 7x xy. Okay, so this x squared term and this y squared term, all right, have both independently given their x, one of them, and their y, one of them, to the middle term. So that then means that this is what we call an advanced trinomial. Okay, and depending on who you are, I know learners have different types of methods that they use to factorize these kinds of questions. Okay, so depending on who you are, you will use a method that is most applicable to you. So for instance, there is what I call the grouping AC method. They call it the grouping AC method. I know there's other methods, guys, that people use to basically factorize this very easy. Okay, yeah, but this trinomial is not a trinomial that a grade 9 learner will get asked, all right? But a grade 10 learner will be asked this trinomial, and it's specifically taught in the grade 10 level. Unless a grade 9 learner is doing accelerated maths, then of course it's another story. So 2x squared minus 7xy minus 15y squared, the grouping AC method. So the grouping AC method goes like this. Step number 1, you take the coefficient of the first term and you take the last term. So in this situation, we have a times c. We multiply a and c. So that is like multiplying what? 2 times 15. What do we get? We get 30. Okay, so this is a method that anyone can do without having to play trial and error, try and guess the factors. Because remember, you need the factors of 2 and you need the factors of 15, and they vary. There's many factors of 15. There's 15 and 1, there's 5 and 3. So you need to sort of play trial and error and put them in a way that will basically help you out. If you've never seen it, well, you are seeing it for the first time. Hello, no bunhle. 2 times 15 is 30. Right? We see that? Okay. Now, listen to this part and listen to it well. The middle coefficient is negative 7. Okay? Do we get that? Middle coefficient, negative 7. So now what we are going to do is we are going to look for factors of 30. All right. So we know 15 and 2 are factors of 30. We also know 5 and 6 are factors of 30. We also know 3 and 10 are factors of 13. What we do here is we try and look specifically. Okay, sorry, what did I say? I said 2 times 15. Remember, the coefficient of 2 is positive, the coefficient of y squared is negative. So I was supposed to say negative 15. That gives me negative 30. So now I'm going to try and look for factors of negative 30. All right, which when I add together will give me the coefficient of negative 7. Factors of who? Of 30, who when I add together give me negative 7. So of course, since this is a negative sign and I'm seeing a negative number at the end, that means my biggest number needs to be negative. All my big numbers here need to be negative. But then my small numbers, they need to be positive for each factor. So what's negative 15 plus 2? What do I get for negative 15 and 2? I get negative 13. You guys already see the numbers, very good. What's negative 5 plus 6? I get negative 1. What's negative 10 plus 3? I get negative 7. So it seems like you guys can see the combination that will work best. You can see the combination that will work best, right? Negative 10 and positive 3. Okay, let me repeat this again. What did I say from the beginning? I said the advanced trinomial can be factorized. Maybe you have a method and it works, but some learners may not be able to use this method that you can use, so others may find this method a little bit more learner friendly and it can help them out. So what I'm saying is, what you do first is step number 1, you take the coefficient of the first term, you multiply it by the coefficient of the last term. So 2 times negative 15 gives you a negative 30. We start there. We always take the coefficient of first and last, we multiply, we get the answer. Then we ask ourselves, what are the factors? We look for factor pairs of 30, right? The most appropriate ones. Maybe sometimes you don't have to list them, but you may mentally be able to see, okay, in your head, 15 and 2, no. 5 and minus 6, no. 3 and minus 10, yes. But look at this. Since this is negative 13, you can see that your coefficient is negative. Of course, that would mean that for all of the factors, your highest factor must be negative. Because in order to get a negative answer, you need to actually add a big negative number to a positive number that is small, so that you can get an outcome that is negative. I'm sure you can see all these outcomes when I add them give me negative numbers. That is what I am aiming for, a negative sign. But specifically, I need the one that gives me negative 7. So if negative 15 plus 2 is not going to work, this one's going to work. This one is the one that works. So listen now. Remember, this was negative 7xy. So that means these also need to be positive 3xy and negative 10xy. So what I'm going to do, I'm going to take this combination and come and replace it in the place of negative 7xy. What am I going to do? Take this combo, come and replace it here. So now I have 2x squared, right? Maybe let's say minus 10xy plus 3xy minus 15y squared. Okay, so let's forget, sorry, I wrote equal to 0. Am I doing that? No. Okay, then remember I said this is the grouping AC method. Now, as a grade 10 learner, the other type of factorization that you know is how to factorize using what? Grouping. So you can group the 2 terms that you know would appropriately give you a highest common factor and lead to a common bracket. Group the 2 terms which you know would have a highest common factor and lead to common bracket. So MathsIsAGame is like chilling there and like, yeah, I think the first 2 terms, they fit. They are a couple. The last 2 terms, they fit. They are a couple. Do you see, guys, the beauty of waiting for this Mr. and Mrs. Right, for the appropriate time, and not sabotaging and, heading for Mr. and Mrs. Right whilst you're still in high school? Such a distraction in high school. Now, you wait for Mr. and Mrs. Right in the right time. Hopefully, you will have waited and they'll be so happy that you waited for them as well. Anyways, so we can now pair the common, the 2 terms that will give us the highest common factor. So we're going to look at these 2. And I'm not going to put any brackets around them. I'm just going to look at these 2 and take out the highest common factor here. So 2x squared minus 10xy. What's the highest common factor, guys, between 2x squared and minus 10xy? Hopefully we can see the common factor. It is 2x. Take out the common factor sign, which is positive. Common factor number between 2 and 10 is 2. Common factor letter between x squared and xy. The common variable that has the lowest exponent is x. Then, what are we left with on the left? X. What are we left with on the right? Thank you, MathsIsAGame. We are left with negative 5y. Let's look at the last 2. Minus 5y. Be careful, user 6489. If you took out 2 times what gives you 10? If you write negative 10, why? 2 times 10 doesn't give you 10, it gives you 20, so you've written the wrong number here. Be very careful when you are taking out a common bracket. What you bring back 2 times, that should give you that. If 2 times that gives you something else, you are completely bonkers. Make sense? Last two. Highest common factor between 3xy and minus 15y squared. It's a deadly mistake, that one. It turns a 99% in a test to 100%, and then you cry. Like some of my learners, and many of my learners that I'm teaching here on this MathsIsAGame platform, who tend to get 99%, and they cry to me, and they're like, "Sir, I missed the 100% for the term." And I'm like, yeah, well, you see, silly mistakes. Last two terms. Highest common factor 3xy minus 15y squared. Highest common factor between 3 positive and minus. The highest common factor, remember the sign that we take out is the positive 3. Okay, positive sign. 3 and 15, 3 is the highest common factor number, and you guys are 100% correct. It's 3y. What's left over? X minus 5y. Oh, looky there. Looky here. Common bracket. Common bracket. Common bracket. And this time round, guys, the highest common factor sign and number, right? 2x and 3y, there's nothing common. So I can go directly to the common bracket and say x minus 5y with no worry at all, which leaves me with 2x at the left plus 3y on the right. And you know what, guys? There's nothing that you can factorize further in both brackets. So that means this is our answer. So factorizing this trinomial, okay, can be done using the grouping AC method. Maybe you feel that, no, this grouping AC method, so it's too long. It's too laborious. Me say I factorize trinomials of this nature in another way. Well, if you do that, then great, my child. Maybe your first step leads directly to the answer. Great, my child. I'm so proud of you, my child. Keep it that way, my child. Don't change your ways, my child. Okay? All right, my child? Oh, my child. I'm so proud of you, my child. Okay. Okay, I think we get the point, right? Okay. So that is just a taste. Now, just because I've done these problems, don't think now your test will be these problems. This is just the skills that we're supposed to have as grade 10 learners who are preparing to write paper 1. We should have these skills. Let's move on further. Where's the young lady who was the one that said, do question 3? Is she still here or gone? I forget the name as well. Very interesting name. Very interesting name. Okay, Cinnamon Girl, you were definitely here. But there was Dandy so-and-so. I don't know if Dandy so-and-so, I think that was the one. I forget the name now. The comment section is not happening. But Cinnamon Girl, you've been holding it down there with your cinnamon bun. Thank you for holding it down. Let's move here, guys. 2.3.1. Simplify the following expression. Now, I want to quickly say, if you look at this question, these are 2 expressions, 1 expression in the numerator, 1 expression in the denominator, and basically, if you look at these 2 questions, they both need what? They need our skill of factorization. They need our skill of factorization. We need to know how to factorize this, and we need to see that we cannot factorize this one. Hopefully you can see with your eyes that even though this looks like a trinomial that could potentially be factorized, where are the factors of 36, which when you add give you 6? Okay, because the factors of 36, you have 9 and 4, you've got 6 and 6, and that's 12 and 3. None of them, when you add them, gives you this. So basically, no ways that this can be factorized. But these kinds of questions, this is division of 2 expressions. So we need to factorize, then cancellation happens. This here is division of 2 expressions divided by a division of 2 other expressions. So once again, factorization is needed, and then cancellation and simplification in that way. Then this one is subtraction of 2 fractions. Subtraction of 2 fractions, we know we need to find and we factorize the denominator, we find the LCD, we make our denominators according to the LCD, and then we simplify from there. So we'll do these three so that you guys can be reminded what it is that we ought to be doing. Let's look at 2.3.1. X cubed minus 216 into x squared 6x plus 36. Denominator, denominator, numerator, numerator. So the rule is factorize. Factorize the numerator. What is this, guys? This is cubic factorization. Hopefully we still remember how to factorize cubic factorization grade 10s. My beloved, amazing grade 10s. We know how to factorize cubic. Still remember? Okay. This is a perfect cube. This is also a perfect cube. Right? So what we do is we open a binomial and we open a trinomial. Right? Since this is a minus sign, we put a minus sign there. Okay? Very important. We put a minus sign. Then it's followed by a positive and a positive sign. I know the signs that follow when we have a difference of two cubes. Okay, Angel M, I'll be doing grade 9 tomorrow morning at 5:30. So good luck at waking up. Actually 5 a.m. 5 a.m. in the morning. 5 to 7 is when I do grade 9. Every morning I do grade 9. Every morning. Okay. I think except this morning I didn't really do it. But and I did sort of like midday, I did a grade 9 paper 2 session where I was dealing with angles on a straight line, congruency, similarity, and quadrilaterals. So I was doing questions that have to do with geometry, paper 2. Okay, I'm going to upload that session. Hopefully after I'm done with the session, I'll upload it on the YouTube channel. So you guys can also make sure you subscribe. Go to the link in my bio. You copy and paste the link. That is the YouTube channel link. It's MathsIsAGame as well. Profile picture on YouTube has a MathsIsAGame emblem, has a white background. You just hop on there. When I upload the video that I've done in the live, then you can see it there and you can watch it for grade 9 maths paper 2. Thank you, Nobuntle. So whatever you're doing, I appreciate you so much. God bless you and I'll pray for you. Thank you. I appreciate your prayers. Appreciate them a lot. So x cubed minus 216. I said this is cubic factorization. For cubic factorization, guys, you open a binomial 2-term bracket and then you open a trinomial 3-term bracket. Okay. No Chantal, no grade 11. Grade 11 I'm hoping to do tomorrow, hey, in the evening. Okay. So no grade 11 today, just grade 10. Grade 10's focus today. I haven't done grade 10s in a while, and grade 11s I haven't done in a while. So, but as I've been doing grade 12, you know, grade 11 has been touched. So, but yeah, we'll do that. When are you writing, by the way, Chantal? If you're saying grade 11, is it you who's doing grade 11? And when are you writing grade 11? Johnny Kimang. Whatever, bro. Whatever. Okay, Johnny is next Friday. Okay, yeah, I'll be having some sessions as well next week, so you just need to watch out for them. I'll have some evening sessions for grade 11 definitely, because I know there's a lot of grade 11s that are writing next week and there's a lot to be covered. So x cubed minus 216, like I said, you open a binomial bracket, you open a trinomial bracket. So the first bracket is going to be aligned according to the sign. Okay, so let me just give you guys a let's just look at two so that I can familiarize. If it was sum of two cubes, you open a binomial and a trinomial. So if it's sum of two cubes, it means you are going to have a plus for your first bracket because your expression itself has plus. Then you are going to say minus plus. This is the sign of your middle term. This will be the sign of your last term. This is kind of like the sign combination when you have a sum of what? Of two cubes, guys. Okay. What about a difference of two cubes? You open two brackets as well, one binomial and one trinomial. Since this bracket is minus, the expression is minus, it means your first bracket will be minus. Then you have plus, plus for your brackets, okay? But this is not done. This is just the signs inside your bracket. That is not your answer. Remember now, what you want are the terms inside the bracket. The signs are already taken care of. And that's why, guys, I am actually showing you that if you have a plus for a sum of two cubes, you open a binomial and a trinomial bracket. Your first bracket will be positive. Then you'll have negative positive. That's for when you have plus, a sum of two cubes. But if you have a difference of two cubes, okay, your first bracket will be negative according to the expression. And then you'll have plus plus. That's what I'm saying to you guys. Now, how do you get the actual terms inside the bracket? Listen and listen to me well. You first take the cube root of the first term. What is the cube root of the first term? It is x. eFootball guy, I see your answer. Thank you very much. Very good. The cube root of x cubed is x. Okay, because it's x to the power 3 over 3, which gives you x. You see, we divide by the exponent, and that by this 3 that is there. The cube root of 8 for the second term is 2. Does that make sense? So our first bracket is going to be x. Where did the x come from? The cube root of x cubed. Where does the 2 come from? The cube root of 8. Okay? Then, to get the first term in the trinomial bracket, x times what is x cubed? It's x squared. For the last term of the bracket, 2 times what gives you 8? 2 times what gives you 8? Let me give people a chance to comment in the comment section. 2 times what gives you 8? Or what is 8 divided by 2? Thank you, Sibusisiwe. Thank you, Cinnamon. So it's 4. Then, guys, the middle term is simply found by multiplying the 2 terms in your first bracket. Forget about the sign. Just multiply the x and the 2. What do you get if you multiply the x and the 2? 2x. This is completely factorized. Are we together, people? Okay. So just the signs, the combination, plus, because it's plus here. Then you have minus plus. To get the first term, you take the cube root of whatever the first term is. That gives us x. That's where the x comes from. Then you take the cube root of the second term. Cube root of 8. So not the square root, the cube root. Sorry. Cube root of 8 is 2. You can just use your calculator. Cube root of 8, you will get 2. There's the 2. Then you want the first term in this bracket. So you ask yourself, x times what gives you x cubed? Or you can square the first term to get the first term in the trinomial bracket. So that's x squared. Okay. To get the last term in this bracket, you ask yourself, 2 times what gives you 8? Or you can say, what is 8 divided by 2? That gives you what? 4. Then in order to get the term that is in the middle, you simply multiply these 2. Never mind the sign. Just say, what's x times this 2? You get 2x. Remember, you had already had your sign. You just write 2x. That's it. That's it, guys. Simple as that. Okay? And what you do notice is that the middle term is always opposite this sign. You see the middle term? This is plus, but the middle term is opposite the middle term. Come here, look at this. If you think I'm lying, you see the minus, but then the middle term is opposite this sign. You see? Okay, so we do the same thing. What's the cube root of x cubed? That's x. So we write x in there. What's the cube root of 8? That is 2. So we write 2 there. What is x times what gives you x cubed? Or what is the square of x? X squared. I mean, that's what when we multiply together gives me back that. 2 times what gives me 8? That's 4. And what's beautiful is that a negative times a positive gives me that negative sign back. Then what did I say? How do we get the middle term? Let's see if you guys were listening. How do I get this middle term? How do I get it again? The middle term? Okay, the sign's already taken care of course. But how do I get this middle term again? Thank you, Al. We multiply the 2 and the x. So basically, we multiply this and that. Never mind the sign, guys. We just multiply the x and the 2. We multiply the respective number and variable, forgetting about the sign that is in the first bracket. So we get 2x. And what do you notice about the sign here? It is opposite those two signs. What do you notice about the sign in the middle? It is opposite those two signs. So that's how you know everything is kosher, everything is pashash, everything is awesome. Let's go back to your question, the one you were doing. X cubed minus 216. Remember, the sign is negative. When we factorize, binomial bracket, minus as this. Then here, plus plus. Okay, sense? Sense. Cube root of x cubed. What is the cube root of x cubed? It is cube root of x cubed. Thank you, with 0. It is x. The cube root of 216. Thank you, Moses. Moses is like on the money there. X times what is x cubed? We square the first term. 6 times what gives you 216? $36. And in the middle term, to get the middle term, as Cinnamon Girl said in the comment section, simply multiply these two, forgetting about the sign. It is 6x. But take note in the denominator. Take note in the denominator. And you know what? Poor old me is going to put the brackets around the denominator. Now, like I said, we factorize, then we cancel what's common, top, bottom. We don't cancel what's common, top, or we cancel bottom. No. If it's at the top and there's something at the bottom, remember the relationship of x minus 6 with this bracket is one of multiplication. The relationship between what's in the numerator with what is in the denominator is division. When we divide things that are the same, what happens? We get an answer of what? Of 1. We don't cancel top. No. We cancel what's at the top, which is common with what's at the bottom. Please, guys. Otherwise, that's where we start having problems if we want to cancel top. So since this and that are common, we are left with 1 and 1. In the numerator, we have x minus 6. When multiplied by 1, we still get x minus 6. It's over what? 1. But then finally, our answer is x minus 6. We end right there. Okay? We end right there. So I hope, guys, grade 10s, the cubic factorization is coming back to us. and we can see how easy it is to simplify. So the steps when we have division of expressions is simply to factorize the numerator if possible, factorize the denominator if possible. Then after factorization, we play the cancel game. We divide and cancel and get the answer. Please guys, it's as straightforward as that. So these should not be complicated. What is needed is your fluency and accuracy in factorization. When that is down, you are good to go. Let's look at this one. This is a typical, what grade? Grade 9. Even grade 9s are doing this question. Okay, grade 9s are doing this one, even though it's a grade 10 question. Okay, expression at the top, there's a factorization that can be done here if possible. Expression at the bottom, there's a factorization that can be done here if possible. Divide, we know from primary that divide, no, Kanye, grade 8s will be limited because grade 8s have not done factorizations. Grade 8s don't do factorization. Okay, divide from primary, yes, cinnamon girl, divide must change to multiply. Very good. X minus 6, okay, that is as factorized as can be. This here needs an application of the procedure, okay, that procedure that we spoke about, because if you look at the order, maybe cancellation with something else won't happen because the order is just a bit jaded. The constant term comes before the variable and it rather would be something else. You know what I mean? Okay, so let's proceed first and say x squared minus 36 over x squared plus 3x minus 18 times, now 9 minus 3x at the top with x minus 6 at the bottom. Yes, we change the division sign to multiply, we flip the fraction. 9 minus 3x is in the numerator, x minus 6 is in the denominator. That's what happens when divide changes to multiply. That's the first mark you would possibly get for this question. Being able to acknowledge that when there's a division sign, we change it to multiply, and then our fraction, it flips the inverse of the fraction. Let us go on. Now we are ready to do what? To play the factorization game. What do you see here? What do you see here? What type of factorization here? Highest common factor is 1, but 1 is not significant. It does not change anything if we take out 1. So then we move on to the next type of factorization. Very good. DOTS. Difference of what? 2 perfect squares. X squared is a perfect square, variable with an even exponent. 36 is a perfect square. There's a certain number that is multiplied by itself to get 36. So what do? We open 2 brackets. The square root of x squared, for our first term we write x. Square root of 36, we write 6 and 6. And then do you remember what I said about the signs inside the bracket? Let's see. Minus means different. Minus means different signs. So that means I'm going to have a positive and a negative. Factorization of the numerator done. I would get my mark for factorization at the top, and it would be 100% marks. Ooh, this is a trinomial, but it is not the advanced type of trinomial because my coefficient of x squared, unlike this one, is not greater than 2, okay, where it is not a highest common factor. Because when the coefficient of x squared is not that, it's not 1, it's something else, and there's no highest common factor that is greater than 1, then basically we know it's an advanced trinomial, and our approach would be like the one that I had explained. But this one, it is a nice sweet trinomial. Here we just open 2 brackets. X squared, we know key x and x. That's what gives us x squared. Negative 18. The factors of negative 18. When we multiply, we get negative 18. When we add, we get positive 3. The factors of negative 18. When we multiply, we get negative 18. When we add, we get positive 3. Who are they? Cinnamon Girl says 6 and 3. Who is positive? Remember, when the constant is negative, it means we are going to have different signs inside the bracket. When the constant or the last term is negative, it means we are going to have different signs. It is no different here. When the constant or the last term is negative, we are going to have different signs inside the bracket. But this one means the highest factor from the factors of 18 is going to have a positive sign. The highest factor out of the factors of 18 is going to have the sign of the middle term. The highest factor out of the factors of 18 is going to have a positive sign. I repeat, the highest factor out of the factors of 18 is going to have a positive sign. Cinnamon Girl, I love you a lot. Thank you for changing that sign. So Cinnamon Girl, please be always aware of this, that if your constant has a negative sign, right, it means different signs. But your biggest factor or your biggest number takes the sign of the middle term. I like what user 64899999896 say. The bigger number takes the sign of the middle term. The bigger number takes the sign of the middle term. The bigger number takes the sign of the middle term out of the factors of 18. So as you said, Cinnamon Girl, thank you. Positive 6 minus 3. Positive 6 minus 3 gives me plus 3. But positive 6 times minus 3 gives me minus 18. So even before I leave this step, let's just quickly check and verify that it actually really confirms the product giving me negative 18, the summation giving me positive 3, and I can see that is the case. I move on. Here, change the sign on the outside, my leader. Change the order. Okay. Took out a negative, change the order. I take the negative back, I get this back, you see? But now I need to take out even the highest common factor and simplify further. So let's just complete the factorization for all my numerator, denominator, and everything that's there, so that I can play the cancellation game with everyone having the chance. Highest common factor between 3 and 9, it's 3. And then I'm left with x minus 3 over x minus 6. Let us now play the cancellation game. Mpo, I'm glad that you feel I am making it easy. Oh, sorry, you're saying that's easy, bro. Okay, no, that's great. I'm glad you feel it's easy. Remember, for some people, it's not, but for you, I am glad it's easy. You must continue allowing maths to be easy. Then I'm expecting you to send me an inbox message and say to me, say I got 100% for maths, how easy it is, you see? Yeah, I don't understand the signs in the triangle. Please do further. Okay, now we can play the cancellation game. So this x plus 6, remember I said we cancel top and bottom. Okay, I prefer, guys, that whenever you play the cancellation game, use a pencil, you know. That's 1 cancelled. Okay. That's 1 cancelled. That's x minus 6 cancelled. Now if you look at the top, everywhere I've cancelled, we are leaving what? The number 1. The number 1. the number 1. And remember, the relationship is 1 times 1 times negative 3 times 1, which in the numerator gives you negative 3. In the denominator, 1 times 1 times 1 gives you 1 in the denominator. When you eventually simplify, what's negative divided by positive? That's negative. And what's 3 divided by 1? That is 3. That is our final answer. Okay, do you see how nice this is? So this means really, say, like you said, our factorization needs to be on top. It needs to be top notch. If our factorization is good, then you'll find that these questions can be done with such beautiful ease. You know, there's no issues, there's no problems, there's no challenges when our factorization is top notch. But then the problem is when our factorization is not on par. You see, when our factorization is not on par, that's when things go south. All right, they go south very badly. Okay, nice question, eh? Nice. Okay, I want to do this one now. These ones had division and multiplication only. So when there's division and multiplication only, it's factorization, then we play the cancellation game. Factorization, play the cancellation game. Places where there's divide, we change divide to multiply, and after that, we play the cancellation. We factorize, we play the cancellation game. Apply the sign change rule sometimes when it's applicable, factorize, then play the cancellation game. Where we cancel, remember, we cancel top and bottom only, where it's common, and then we leave ones where cancellation has happened between common things. Okay, so important, these things, so important. Let's look now at this one that has addition and subtraction. This is not divide, but this is addition and subtraction of an expression. Okay, so now we have to simplify this one. 6 marks, makes sense that it would be 6 marks. Okay, this is still it's an expression. We need to simplify the expression. So look at this, guys. I would like to ask how long the live, I would like to see question 1 of functions plays after this. No, I'll show you question 1. You can screenshot, do it on your own, and then or maybe if there's something in particular that you might think you might have a challenge with, you know. So I think today I'll have to do just part 1 of this paper 1, and then I'll have to do part 2 with you guys as well. Maybe, I don't know, Sunday. Okay, and I can continue further. Yeah, it's grade 10, Grootman. It's grade 10. Of course, it's grade 10. Okay. So first things first, here, this is addition and subtraction, okay? And as you can see, there is no simplification or factorization that can take place for this first fraction. Let's look at the second one. This second one, let's first rewrite the order of this trinomial. Negative x squared usually starts, the 8x is positive, and then the 15 is negative 15. Okay, I think now we have the order, that's fine. Okay, so now our fraction is okay. Then let's go to the denominator, because that's the first step. Our denominator needs to be factorized. You know, with addition and subtraction of fractions, denominator must be factorized. You must make sure it's factorized if possible. So if you look at this denominator, there's nothing more we can do. It's x minus 3, that's fine. But if you look at the other one, this one needs to be factorized, and we actually need to do a 2-part factorization. So first step, negative x squared plus 8x minus 15. Our first term is what? Is negative. So we take out a negative sign. Then, after taking out the negative sign, we write what's left behind. If we take out the negative sign, we are left with x squared. If you take out the negative sign here, we are left with negative 8x. If you take out the negative sign, the negative times what gives you a negative, that's positive 15. All right. Now, please take note of something here that's very, very important. Do you see this negative sign? multiplied by this negative sign. You have this negative sign multiplied by that negative sign. That makes it so that this negative times this or negative divided by negative gives us a positive 2 over. Now, that negative sign has actually been multiplied by that negative to give us a positive in between the terms. Okay, I hope this makes sense. Remember, you took out the highest common factor of negative. That left us with x squared for the first term, minus 8x for the second term, plus 15 for the last term. Do we understand that so far? X squared for the first term, 8x, negative 8x, that is for the second term. And then this negative 15 changes to positive when you take out the negative. That's positive 15. Okay. Then this negative divided by the negative gives you a sign in the middle. That's no longer negative, but it's what? Positive. Now let's factorize what we have in the bracket. Negative sign has been multiplied, it's positive. Let's factorize this. Now, please be with me here. This plus sign means what? Unlike when there's a negative sign, we know it's different signs. But a plus sign suggests that in the brackets, we are going to have the same signs. Guys, I need you to listen to this. Plus means same signs. According to who? Go to any home where there's a father and a mother. The father, which is like this positive 15, may think that today's mood in the household is supposed to be a positive one. But listen to me, guys. There are those special creatures in that household of yours, which they call mothers. They are the ones that dictate the mood of the household. So this 8x is like the mother. This is like the father. If the father is positive and it just so happens that the mother is negative on that day, trust me, the whole household, I promise you, will be negative. This only happens, guys, when the father is positive. Remember, I said for positive sign, this means same sign. Same sign according to who? According to the mother. So if this is positive, this means same sign. According to what, guys, that is the same sign? According to the sign of the middle term. So minus, minus. If this was plus and plus, that would mean same signs according to who? The mother. So the father is positive. The mother is already positive. So the whole entire household can be positive. Okay. So this is negative, negative. That's the sign inside the bracket. Then x squared, obviously x squared, it's x and x. And then 15. What are the factors of 15? You multiply, you get 15, you add together a negative and a negative, you get negative 8. That will give you which factors do that. Is it 15 and 1? It can't be. Is it 5 and 3? Seems like it. 5 and 3. Okay. So far we good. So that is first step. In the denominator, we factorize. Okay, and we must be very affluent with all types of factorization. Sign change, that can happen potentially. Difference of two squares, trinomial, grouping, common bracket, cubic factorization, the works. So we are now at the place where we have factorized. There's no other factorization in the denominator that can or should take place. What is the next step after denominator has been factorized? The next step is we need to find the LCD, and after that we need to write down our restrictions. Okay, our restrictions. So let's first start with the LCD. What is the LCD? LCD means the common bracket that has the highest exponent. Okay, so let's look at x minus 3. X minus 3 is what? It's common. X minus 3 is underneath this first fraction, X minus 3 is under this first fraction. So that means we write X minus 3 as an LCD. We write in brackets. X minus 5 is not common, but because X minus 5 is there and it is unique, we write it as a common, lowest common denominator, as a product with X minus 3. So our entire LCD is X minus 3 and X minus 5. But the restriction is that X cannot be what? It cannot be 3, because 3 minus 3 is 0. And guys, what do we know about a denominator that is 0? If X is 3 minus 3 in the denominator means that the fraction is what? If there's a 0 in the denominator, division by 0 means what exactly, guys? And I hope you understand why now I write the restriction. Okay. If we divide by 0 for any fraction, it means that the fraction is undefined. Very good. Undefined. So we say X cannot be 3 or X cannot be 5. Okay, guys, undefined is what I was looking for. Okay, undefined. Okay, undefined. So that's why we write down the restrictions. So denominator we factorize, we find the LCD, we write down the restriction, then we use the LCD so that all denominators subscribe to the LCD, because this one is an expression. Okay, different from when we were if we were to be solving an equation, but this is an expression we are expected to simplify. So this is what you then do. X minus 3, this denominator, does it look like this denominator? No, it doesn't. This denominator does not look like the LCD. What's missing in order for this denominator here, X minus 3, to be the same as this denominator? Busisi where it says multiple. Okay, so we need to multiply this denominator, which is X minus 3, by X minus 5. But remember, what we do at the bottom, we must do where? At the top. So if you multiply by X minus 5, it must be the same for the denominator there. We are done with the first first fraction. Look at the second fraction. Does the first fraction look like the LCD? Well, look at here, it does. So there's nothing we can do further with this particular with this particular denominator. We just need to just times by what? By 1. Because we times that by 1, we still get that LCD. What we do at the bottom, we do at the top. Okay. So we use, guys, this is very important, use the LCD so that all denominators actually subscribe to the LCD. All the denominators. So you multiply by what's missing. What you do at the bottom, you do where? At the top. What you do at the bottom, because remember, what informs what we are doing at the top is what we are doing at the bottom, because we are checking what is missing as far as the LCD. Now, if you don't write down the right LCD, how can you then do this? That's the million-dollar question I ask you. Now, I think you guys can see that our lowest common denominator is simply what? X minus 3 into X minus 5. It's common. Okay. Okay, LCD stands for lowest common denominator, yes. Then we can take the left, X minus 2 into X minus 5, and do what? Distribute. So we are going to say X into X, X into minus 5, negative 2 into X, and negative 2 into negative 5. That gives us what? X squared. X times negative 5, positive times a negative, negative. 5 times X, 5X. Negative times a positive, negative. 2 times X, 2X. And then a negative times a negative is positive. 2 times 5 is 10. Then here we are adding. Remember, when the denominators are the same, we can do what? We can add the numerator. Hence, we can now add that 2. because the denominators are the same. That's the rule of fractions. When the denominators are the same, you can add the numerators. Now, final answer. We say x squared. We check the like terms. Minus 2x minus 7x is negative 7x. And then 10 plus 2 is what? Is 12. Okay. Now, it seems like I can still factorize further. Okay. It seems like I can still factorize. Let's look at the numerator. Okay. I'm looking at this and I'm like thinking, we have x squared minus 7x plus 12. This constant term is positive, and it seems like I can get the factors of 12, which when I multiply give me positive 12, when I add them give me negative 7. What are those factors? The factors of 12. So it means I actually have, firstly, positive means same signs. According to who? According to the mother. So we have a negative and a negative. X and X, it's negative in that household, even though father was thinking it's going to be a good day today, but mommy is not feeling in a good mood, and it therefore means that we are going to be eating burnt charcoal for supper because mommy is not in a good mood. The food is probably not going to taste as good. So we have those factors, which are 4 and 3 over x minus 3 into x minus 5. Whoa, look at this. You can play the cancellation game. So I grab my pencil, play the cancellation game. And that pretty much ends it. Now I know some people, they think you can cancel this x and this x. You can't. Guys, we can't cancel across an addition and a subtraction sign. We leave the answer as this. Okay. We cannot cancel across an addition or a subtraction sign. We can't. I will, guys. I will. I will. Great hands. Okay. You're welcome, Cinnamon Girl. So those who are eager to know what is there in question 1, everything that has to do with number systems. State if the following is true or false. Integers, whole numbers, and natural numbers are all rational numbers. True or false? Let's see if you guys can know. Integers, whole numbers, natural numbers are all rational numbers. Is that true or false, guys? Okay. Then 25, with the 5 with the dot at the top. They are asked, is this an irrational number? Is it? That's the question. Is it really? Square root 26 is real and rational. Is it? And then lastly, there is always an irrational. Okay, I think guys, yeah, for the most part, like I was saying, you guys need to know about the number system. You need to know it very well. You need to know the number system. You need to know all that there is to know about the number system. Okay. Yeah. And some of these questions here are very, very, very good. Look at this one, for instance. You need to know how to round off. You need to know how to represent, number sets on a number line. Whether it's set builder notation, how to represent it in a number line. Interval notation, how to represent that on a number line. Okay. Yeah, I'm sure you guys know what I mean. Also, you need to know how to write this into set builder notation. Represent this in set builder. Represent that in set builder. Represent that in set builder. Or vice versa. Represent that in interval notation. Okay, and vice versa. Very important to know these things. Between which two integers do certain irrational numbers lie? You need to know how to do that. You need to know how to convert recurring decimals into rational numbers. Okay, and remember as well that recurring can either be a dot on top of a number or a line on top of a family of numbers. That all means recurring or repeating. Okay, yeah. For instance, think of this as well. State for which values of x will this expression be undefined. When we talk about undefined, you need to know that we are focusing on the denominator. What value of x will lead to this denominator being 0? Because division by a 0 number means undefined. So which value of x will lead to this expression being undefined? Okay, these are important things. So it's when x is equal to -2. Very good, cinnamonical. State for which values of x will this expression be non-real. You need to understand that when we say non-real, we are looking at the expression underneath the square root. And then specifically, what are we interested in underneath the square root? We are interested that that expression is less than 0. Because if that expression is less than 0, we know the value of x, which would make the entire expression become something that is negative. So then we can solve this inequality. Okay, so any value that is less than 2 will lead to this expression being what? Being non-real. Okay, where of course x cannot be -2. Okay, makes sense? So when x is less than 2, so think about it. If x is less than 2, think of any number that we put here. What is a number less than 2? Let's think of a number that is less than 2. Give me one number that is less than 2. Any number. Any number, guys, that's less than 2. Great hands. Think about any number that's less than 2 and give it to me. Okay, a number that's less than 2 is like -2. Okay, so let's check. -2 minus 2 gives me -4. And -4 underneath the square root is non-real. Makes sense? So that makes the entire thing non-real. You guys said 1. 1 minus 2 is also what? -1. A negative number under square root is also non-real. So the whole entire family of numbers that are less than 2, if substituted in this, x minus 2 expression, will lead to a negative number inside the square root, which would in turn make the entire thing non-real. Because what does non-real mean? It always refers to a negative number underneath a square root. Please, guys, these are easy peasy marks, but these marks, many learners, because they don't understand the concept of undefined and understand the difference between undefined and the concept of non-real. These are two things that mean two different things. Undefined means division of a fraction by 0. Undefined means division of a fraction by what? By 0. So that's why we say when we're solving for which values of x is this undefined. We say 2 plus x is equal to 0, then we solve for x. That's for undefined. We are always looking at the denominator for undefined. If they say non-real, we are looking at the expression underneath the square root, and we are checking this expression, when is it less than 0? Then we solve for that x values. It's when x is less than what? Than 2. You guys have all indicated values that would basically be what? Be less than 2. But in all of those values that are less than 2, we must be careful to put the restriction, guys. Okay, there's only one restriction. X is less than 2, but x cannot be negative 2. The thing is, even though we are saying x is less than 2, there's only one value that we must avoid in ensuring that this expression remains non-real. X can be any value less than 2, but we cannot make that value of x be what? Be negative 2. Because even though negative 2 minus 2 gives me non-real at the top, the thing is 2 plus the negative 2 in the denominator will lead to a what? It will lead to an undefined number. Tina, we want just non-real. We can't have undefined as well. So we say x is less than 2, but then we specify that x cannot be negative 2. That is the full answer to number 3. Okay? Yeah. Aye, guys, the rest, you need to be able to know how to do. You need to know how to do these ones. Okay? I'm thinking of this one, for instance, converting this into a rational number. Guys, let x be equal to 128,818,818,818,818. You multiply by a certain 10 to the power something, both left and right. You set up two equations. You solve for x. You get the actual fraction that basically indicates that 128,818 is a rational number. Okay, so when you convert it to a fraction, guys, practice those questions. Okay, moving right along to this one. Okay, we have exponents here, addition and subtraction of like terms. Okay, we would add these two, we get 6x cubed. We would subtract these two, we get minus 15x to the power 4. And then obviously the unlike terms, the 6x cubed and the minus 15x to the power 4 are unlike terms. We leave those two terms as they are. The laws of exponents, guys, hopefully you know how to apply laws of exponents. You know, this negative 2, you know, the fact that you can actually rewrite this fraction as 4x squared in the numerator with negative 2x to the power negative 2 in the denominator. You change that exponent to positive 2. You could do that, or you could actually not do that, but start out by distributing the negative exponent. Since it's even, it means this negative sign is going to change to positive, because an even exponent applied to a negative sign leads to a positive answer. You apply the 2 to the power negative 2 here, the x to the power negative 2 times negative 2, you get the answer there. You do the same, you apply the exponent to the denominator, because for division, the exponent can be applied. You apply the exponent to the what? To the sign. If it's even, to the number, to the what? To the letter. And to the sign at the bottom, the number, the letter. By what you know is the rule. Board mess, guys. Bed mess. Bed mess. Bed mess. Okay? Division comes before multiplication. Bed mess doesn't matter. So if you say 6x squared divided by 3x to the power 4, you can get that answer there. Then you multiply it by 8x to the power 8, or you can do vice versa, because bed mess, it can be BEMDAS. Okay, you can first multiply, then you divide 6x squared, you divide by what you've multiplied. So for instance, 8 times 3, that gives you 24. Then the x to the power 4 plus 8 is 24x to the power 12. Then you say 6x squared divided by 24x to the power 12. You actually simplify, you get the answer. Let's remember bed mess. The whole entire bracket raised to the power 0 means this whole entire bracket is equal to what? 1. 1 times 6. Okay, it's only the x that is going to affect the 0. So that's 6. So 1 times 6 is 6. You get an answer of 6. So think about it. everything inside this bracket can just be written, because it's all raised to the power 0, it can all be written as what? Because whatever is in here is raised to the power 0. So that's 1 times the 6 times the 6 times 1, which is 6, the answer. Simplification should be straightforward. Prime bases, 4 and 2, you can change 4 to 2 to the power 2. Remember, guys, hey, this is very important. 2 to the power 2 raised to the power x plus 2. Silly mistake grade 10s usually make is they forget to distribute the 2 to both the x and the 2. Okay, don't forget that. 2 to the power 2x minus 1. So if you think about it, we have 2 to the power 2x plus 4. If we multiply 2 times x, it's 2x. We multiply 2 times 2, we get 4. In the denominator, we have 2 to the power 2x minus 1. Then if the bases are the same, what do? We keep the base, we subtract the exponent. So this will be 2 base 2, 2x plus 4. Then at the bottom, minus 2x, the negative 1 becomes plus 1. Okay, the signs for the denominator, they change the minute we actually do what? We raise them so that the exponents are added and subtracted. Then what's 2x minus 2x? That's 0. What's 4 plus 1? It's 5. So we're left with 2 to the power 5, which is actually equal to what? 32. But look, the question says, simplify the following, leave your answer in a positive exponent. So I would most likely leave the answer as 2 to the power 5. Okay. This is still multiplication and division. There's no addition or subtraction in the mix. So that means we change 12 using that calculator skill. You just say 12 is equal to a shift fact. You get 2 squared times 3. Okay, let's see these things, guys. You get 2 squared times 3, right? All raised to the power x plus 1. Okay. 8 is 2 to the power 3, all raised to the power negative 2x. Over 24, you also press 24 is equal to shift back. This 24 is actually what? 2 to the power 3 times 3, all raised to the power negative 2x plus 1. Alright, then you simplify very nicely. This 2, distribute, you get 2 to the power 2x plus 2. This 3, same thing, there's an exponent 1 there, you distribute, 3 to the power x plus 1. This 3, you multiply and distribute, 2 to the power negative 6x over this 2 to the power 3, you distribute 3 times negative 2x, 2 to the power negative 6x, 3 times 1, 2 to the power what? So it's plus 3, sorry. And then lastly the 3, that's 3 to the power negative 2x plus 1. Now imagine you are going to collect all the base 2's and apply the law. So for at the top, you are going to say 2 to the power 2x plus 2, that's base 2. This other base 2 minus 6x as it is in the numerator. Then in the denominator, this negative 6 becomes plus 6x. This positive 3 becomes minus 3. We are done with base 2. Then you go to times, you collect base 3, its exponent. It's in the numerator, it's x plus 1. When we go down in the denominator, we raise that plus 2x, and then the plus 1 minus 1. Then you add like terms, guys. You have 2 to the power, what's 2x minus 6x minus 6x. This minus 6x plus 6x gives you 0. Okay. Yeah. Gives you 0, guys. 0, 0, 0. Then you are left with 2 to the power 2x. 2 minus 3 gives you negative 1. Then the 3, x plus 2x gives you 3 to the power 3x, and then 1 minus 1 gives you 0. The answers we were told we need to leave as the positive exponents. So I am thinking this is 2 to the power 2x. Then this is times 2 to the power negative 1 times 3 to the power x. This becomes 2 to the power 2x times 3 to the power x over this 2 to the power negative 1 over 2. I think I can leave it like that because they said leave the answer as positive exponents. I don't need to have a negative exponent in the mix, so I need to have positive exponents, and I can just leave the answer like that. Okay. So these are the skills we need to remember, guys. Remember, if there's a plus sign between two terms, remember, guys, that when there's a plus sign, we split. Do you see the splitting that has just happened? 7 to the power 2x plus 1, there's a plus sign, so there are two terms in the numerator. With these ones, it was just 1 everything. Here, 1 everything. But here now we have two terms in the numerator. And what you see is that 7, the base is raised to the power 2x plus 1. Here it's raised to the 7 to the power 2x. So that means there's a common thing, but I need to first split the 7 to the power 2x plus 1 to its respective bases. 7 to the power 2x times 7 to the power 1 plus 7 to the power 2x. Then in the numerator, I can take out the common one. Common what? Common 7 to the power 2x. I'm left with 7 plus 1 over what? Over 2 times 7 to the power 2x. Isn't this 7 plus 1 equal to 8? So we have 7 to the power 2x times 8 over 2 times 7 to the power 2x. This 7 to the power 2x and this 7 to the power 2x, they cancel out. We're left with 1 and 1. Then 8 divided by 2, that gives us 4 over 1, which is 4 as the final answer. So we need to understand the rules that attach to exponents when we have a plus sign between bases, as opposed to when there's just multiply and divide, multiply, divide. Because when there's a common factor, we take out a common factor. If there's any other type of factorization that needs to be done, we need to do that type of factorization. I want to look at this one. Another interesting one. 9 to the power x minus 4. That is all over 9 to the power x minus 2 to the power 3. 1 over 3 to the power negative x plus 12. Okay, I think I'm going to hold it right there for today. What do you think, grade ends? I hope this was really meaty for you guys. You know, like I said, much of what I've kind of rushed, especially now, just rushly did, is to kind of like prick your mind and make you realize that, yay, all right, there's either a lot of work I still need to do as far as like revision is concerned. I need to revise certain aspects. I need to practice other concepts I've forgotten. Or, yay, I'm still good at certain things. I still flow with them. I can still see what needs to be done. Okay, right. So I think grade 10 is what I'm going to do, because, you know, I think to some degree some of you have really been here, and I really appreciate that. Like, I mean, you see, Busisi Wangwanya has been here for ages. E-football guy was here for ages. Tseho, Jared, account not found, who I don't know who it is. Naledi Apiwe, Naledi Apiwe, are you kidding me? No, Lubatanda and Laga, Bell's Art and Kitchen. Okay, some of the people have been here for a while. Very active, very participative, and it's been a very good vibe. I really have appreciated. So I know that maybe in some of those questions that I've answered, it's just been rush, jump from this, jump from that. But like I said, that was just designed to sort of like say to you, hey, okay, some work needs to still be done, which I want to encourage you to go and do that work that needs to be still done, so that you can be good. You know, you can be good. You know, I'm actually tempted to finish off just this one and then call it a night for today. Then tomorrow, I think I'll go live for the grade 10s again, for the purpose of doing functions. Okay, I know many of you cry about functions, but functions are nice actually. They're very delicious. They're very sweet. I just don't want to overload you with a lot today, because I've done quite a bit, and maybe some of you are like, you're okay, I've forgotten that part. I still need to do that part well. I'm glad you appreciate, that's fine. Okay, so are you guys up for having the second part for functions and stuff done tomorrow? Are you good with that? Can we plan on 8 p.m. again tomorrow? I kind of said that grade 11s would have a session with me tomorrow, but maybe grade 10s, are we good to have a live session tomorrow at 8 o'clock, 8 p.m.? It will be Saturday, so you'll probably be having your own fair share of fun. Maybe you have your own plans, but you can just let me know if that's fine. If it's not, then I guess it's not fine. If you miss it, then you miss it. You can always find the live sessions. Like I said, try to upload as much as possible to my YouTube channel. If you miss something, you can always rewatch it and get through the rambling. You can always fast forward, jump, skip, because sometimes I think I talk too much. Like right now, I'm talking a lot. 9 to the power x. This can be written as 3 to the power 2x minus 4 over 9 to the power x, 3 to the power 2x minus this 2 to the power 3, that is 8. 1 over 3 can be written as 3 to the power negative 1 to the power negative x plus 12. Please take note. Okay. 3 to the power 2x minus 4. Let's rewrite this. 2 terms in the numerator. Denominator 3 to the power 2x minus 8 to the power, remember, negative 1 times negative x. You remember I changed the 1 over 3 to 3 to the power negative 1 raised to the power negative x. Negative times a negative, that's positive x plus what? Plus 12. Now, if you have eyes to see, you are going to see that this is dots. If you have eyes to see here, you are going to see that this is a trinomial. So for exponents, guys, they are what we call difference of two squares exponents. Okay, this is a perfect square exponent, and this is a perfect square number. This here is a trinomial. Okay, yeah, this is like your first term, that is quadratic, 8 times, your x variable, and then this is 12. So think about the factors of 12, which you multiply, you get 12, you add, you get negative 8. Okay, because these are just simply variables. So look at this. Some people use K method. Okay, I don't mind if you use K method, but you can factorize this very simply using difference of two squares. So at the top, do you all agree if we open two brackets, 3 to the power x times 3 to the power x, bases are the same. What do we do to the exponents when we're multiplying same bases? X plus x, we add, we get 2x for the exponent. So 3 to the power x times 3 to the power x is this. That's why I'm saying this is a perfect square. What about 4? Square root of 4 is 2 and 2. Okay, then what do we write here? Plus and minus over. Remember I said this is a trinomial. I'm going to open two brackets. This is 3 to the power x and 3 to the power x, which will give me back that 3 to the power 2x. Then my factors of 12. Remember, plus means same sign. According to who? According to the mother, the sign of the mother. So we have negative and negative. Think of the factors of 12, sorry. You multiply them, they give you 12. You add them, you get negative 8. Please don't mind 3 to the power 2x and 3 to the power x. Those are like your variables. Raised to the power 2 and the other one just raised to the power 1. Okay. So that means the factors. Can anyone tell me the factors? Let me not tell you what. What are the factors of 12? You multiply, they give you 12. You add, they give you negative 8. Negative what and negative what? Thank you, Cinnamon Girl. Cinnamon Girl, you must really chow maths. I see you've got a picture of the cross there. Are you a Christian? Cinnamon Girl, icon. And this significance. Why cinnamon as well, actually? Okay, we get it now. Then look at this, guys. This cancels with that. Do you see what was hidden here, which we could not see with the eyes? But the minute we started working, we could, Guys, please practice maths. Let maths become something you do frequently. The more you do maths, the more you can see things. You just see things. You see, someone else could look at this and not be able to move out of this and be like, this question is too difficult. But someone who's been doing maths, practicing exponents, doing question after question after question, you see the patterns, man. You quickly see certain things. They jump at you. So you see who's cancelled then? Do you see what cancelled there? All right. I hope you can. So our final answer is 3 to the power x plus 2 over 3 to the power x minus 6. Now we can't cancel across a what? An addition and a subtraction sign. So our answer, we leave it like that. This is like saying k plus 2 over k minus 6. Can you cancel k plus 2 over k minus 6? No, you can't. We do not cancel across an addition and subtraction sign. We don't. We can't cancel this and this because it's across an addition and a subtraction sign. We can only cancel with this multiply and divide. Okay. Can I leave you now? Are you guys good? Are you good? Do you want more? Okay, so we've just been dealing with expressions and exponents. Of course there's equations, guys. Of course there's equations. Palesa is like saying no. No what, Palesa? What are you saying? What is the no for? Type out what do you mean by the no. What is the no for? No for what? Simultaneous equations? Yeah, simultaneous. Either you use substitution or elimination. Which one is more delightful? Substitution or elimination? Okay, you use the method that is most delightful to you. Okay, yeah, let's not forget that one. It's also there. Okay, this one should be straightforward. Do we really need to do number 5.1.1? Tell me. You tell me. 5 to the power x, 125. What do we do here? No, I actually want to hear people's voices here. Let's see. Okay, none of you have privileges. Okay, you have no privilege. Sorry, still young. Easy, no? Easy. 125 is equal to shift fact gives you 5 to the power 3. 5 to the power x is equal to 5 to the power 3. Yes, happy. 125 is equal to shift fact gives you 5 to the power 3. So you have 5 to the power x is equal to 5 to the power 3. Bases are the same, they are 5. You drop the base, you equate the exponent. The answer is x is equal to 3. Isn't that so great? Tens. This one. 3 is a coefficient. Base 2 to the power x plus 3, that has the exponent variable x plus 3 equal to 192. So this 3 is like a coefficient. What do? We divide both sides by the coefficient, which is 3. So I'm sure you guys can see that 3 to the power 3 times 2 to the power x plus 3 is equal to 192. If you divide this by 3, what's 192 divided by 3? It is 60. Yeah, 64, right? Yeah, so this cancels. 2 to the power x plus 3 is equal to 64. Then I'm sure from there, guys, easy. 2 to the power x plus 3 is equal to 2 to the power 6. Then the bases are the same. You drop the base. X plus 3 is equal to 6. X is equal to 3. Okay, user, I see you very quick there with the exponential equations. Soft, smooth. Okay. Yeah, straightforward, yeah? Nothing much to it. Look at this one. 1024 times 3 to the power x is equal to 4 to the power x is equal to 243. So the question is, if you divide both sides by what? By 243. Divide the side by 243, you divide by what you do on the left, you do on the right. What's 1024 divided by 243? Does that even give me a numerical value, guys? 1024 divided by 243. Is there even such